guys, this is the second part of exercise 6.6 from your Jack Plus book, and we're going to look at combination transformations here. So if you haven't done the individual transformations in the first video, part A for 6.6, you better do that first. So look, I've copied this this list here from the Year 12 transformations exercise because I think it's quite a good summary of all the transformations we have in a function. So I'm just going to get rid of that there because I want to put a negative in. If I have y equals, and I could have a negative out the front there, I could also have a negative inside here, and I can't really fit it in, so I'm just going to put it there. So if we look at each of these transformations one by one, well, the first one, the A, and we're just going to ignore those little lines on the side, that is our dilation factor A, so it might be a 2, let's say it's a 2, y equals 2f, and that's a dilation factor of A, whatever the value of A is, in this case 2, so factor 2, from the x-axis. And as we said in the previous video, we're going to ignore the parallel part for now. We talked about how from the x-axis and from the y-axis makes sense in the previous video, so take a look at that, make sure you understand, leave out the parallel for now. In the n value that they give, so over here, there's an n there, and that is a dilation factor of 1 over n. So again, ignore that little modulus sign there. So dilation factor 1 over n from the y-axis. So again, we talked about that as well in the previous video, and that's where it will sit. So if we have y equals f of 2x, that is a dilation of factor of half from the y-axis. So the first one, I should put the x there as well, was a dilation factor of 2 from the y-axis. No, from the x-axis, sorry. The second one, a dilation factor of half from the y-axis. And in the previous video, I also mentioned that x comes before y in the alphabet. So we can say that the first position that we can have a dilation, that A, is to do with x, dilation from the x-axis. The second position where we can have a dilation, it's to do with y, because y is second in the alphabet there. Our next point here is let me use blue. So if we've got a negative sign here, this is a reflection about the x-axis. So that means if we have y equals negative f of x, well, again, x comes before y in the alphabet. So that means that all our y values have been multiplied by -1. So a reflection about the x-axis affects y. Look at the previous video to see, I gave an explanation of how that works. And we could have a negative on the n value as well, so I wasn't able to fit that in, but that would go y equals f of negative x. And this one, well, let's make that green. This is a reflection in the y-axis, so that affects our x values. So dilations and reflections affect the opposite. So if it's a dilation from the x-axis, it affects y. If it's a reflection in the y-axis, it affects x. The reasonably easy to remember transformations, so our b value there, which often they call negative h, and our c value over, colour haven't we used, red, here. So when it's connected to the x, this is a translation in the opposite direction. Remember, when it's connected to the x, it's opposite, moves the opposite way. So if we had f of x plus 3, that means we're going 3 units in the negative direction of the x-axis. So on our graph there, we would move this point 3 in the negative direction, like always. Go backward by 3. If this was a -3, we'd be going in the positive direction. And of course, our last one, the red there, which is our vertical shift or vertical translation. So this would be if we have, say, f of x plus 5, and that means we go up by 5. So from our graph maybe there at 0, we go up 5 units. So it goes in the same direction, our c value there. So this is quite a handy summary of the transformations here, and you know, you might like to take a good look at that. Let's move down to the examples. And they're asking us to describe the transformations applied to the graph of y equals x cubed to get each of these graphs here. So look, I'm going to draw them. We don't need to draw them because we can refer to our list of transformations that we just saw. But let's have a look. So y equals x cubed is a graph that looks something like this, and really who cares what it looks like? We're not asked to draw it, we're asked to describe the transformations. So what we can see, we have a 4, it's here out the front, and this is a dilation. It's multiplying the function, and I mean it's in the first place, it can be. So remember, x comes before y, so this is a dilation factor 4 from the x-axis. And our only other thing is this -7 here. So there it is, and that means we're going in the positive direction by 7 units because this is connected to the x. It's in brackets with the x. So that's when I say it's connected to the x, we think, well, you know, if it wasn't in the bracket, it would not be connected. So we go the opposite direction. So this is, we can say translate 7 units, I'm just going to write 7 units to the right. So if I had to draw this this graph with the transformations, I could say, well, it's dilated and it's moved 7 to the right. So it's going to be somewhere over here, and this will be at 7, 0, rather than 0, 0. So that would be our new graph. We're not asked to draw it, but just I did just to show how that might work. I'm going to rub that out now so I can use the space. So that's the first one. The second one, now this one looks a little weird because you've got the 6 out the front. So you might think, oh, look, that 6 is in the first place. That must be a dilation. No, it's not, because it's 6 minus, we're adding 6 to this equation here. 6 minus 2 times x plus 5 cubed. So let's rewrite that in a way that's going to be nicer for us to look at and work with. Y equals -2 x plus 5 cubed plus 6. So let's have a look. We've got a negative there. I'd like to use the same colours, blue. And let's see what else we got. Yellow, pink, orange, red. All right, so yellow, pink, orange, and red. So I've just color coded them in the same way that I color coded at the top. There's quite a few transformations there. So the first thing I see is a reflection about the x-axis. Okay, that's that blue subtraction, or that blue negative, I should say. We're not in grade 5, so that blue negative there. That's our reflection about the x-axis. It's in the first place that I could have a negative. I could have another negative in there. That's the second place. So x comes before y in the alphabet, so it's a reflection about the x-axis. Really handy way to remember that. The next thing I have is a dilation factor 2 from the x-axis. And that is the yellow. So I'm just going to highlight that so we can see that's a dilation. Then we just have our translations. So here it is 5 units left. That is in orange because that is connected to the x, so it goes in the opposite direction. Plus would be right, minus would be left, so we go the opposite. And finally we have up by 6 units. So that is not connected to the x, so it goes the same direction. So they are our transformations that we're applying there. The next one, I'm just going to take that down here so I can see it a little better. So this is now written in the way that some people don't really like, but actually I think it's easier to work with than when it's got the actual function. So for a start, we have a negative out the front. Oh, don't want to get that 3. We have this 3 here, and we have the 8, and we have the -9. So our first thing in blue, reflection about x-axis. We then have dilation factor 3 from the x-axis. So x comes before y. They both are in the first place as they can be. We have 8 units right, so in the positive direction of the x-axis. You could say that if you prefer. And we have 9 units down. So let's just color code those so we can see where each one is coming from. Reflection, dilation. Why is that pen so skinny? 8 units right. So horizontal translation connected to the x goes the opposite way, and vertical shift 9 units down, same direction because it is not connected to the x. All right, the last one we have, yes, the last one. So here we have a graph of y equals root x. I'm just going to draw a little picture, not because I have to draw a picture, they're not asking me to do that, but I'm just going to draw that in so we can see what we're dealing with. And it's got 2 transformations in the order given. A dilation factor 5 from the x-axis. And then, actually I might put them in different colours. Followed by a horizontal translation 6 units left. I think I used orange for that, so we'll do that. Oh, that's too fat. Okay, give the equation of the image. All right, well, let's see. Y equals, we have A, which is our dilation from the x-axis. And then we have root x, and we're going 6 units left. So that is to do with our horizontal shift. So it's something connected to the x. So it's something in here, plus, I can't remember what letter they used. I'll use the -h like they often do. So let's now see what those values are going to be. The A value, dilation factor of 5 from the x-axis, that A is just going to be a 5. So y equals 5 root. Horizontal translation 6 units to the left, so we're going this way, so it means it's going to say plus. When it's connected to the x, it is the opposite sign, and 6, not 5. And in year 12, we see how that works. So we learn why it goes the opposite way for x and the same way for y. So that's our equation of the image. So if we want to undo this or describe the sequence of transformations that need to be applied to the image to undo the effects of the transformations and revert it, or in other words, change it back to y equals root x. Well, let's think. I shouldn't have rubbed it out. I started with a root graph, y equals root x, and I said, well, what is my new equation going to be? It's going to be y equals 5 x plus 6, so we've gone in the negative direction by 6, and it's some sort of dilation there. So, well, we're going to have to go backwards. So first of all, we're going to dilate factor 1/5 from x-axis, and then, well, to undo the move of 6 in the negative direction, I'm going to have to move 6 in the positive direction. So 6 units right. So if you think about it, when we dilate a factor of 5 from the x-axis, we're multiplying each y value by 5. So if we're multiplying each y value by 5 to get to here, just say this y value, let's say that's, 2. And then, well, if that's 2, and then we've multiplied each y value by 5, so now that same place is going to be a 10, so we've multiplied by 5. To get back to 2, we're dividing by 5 or multiplying by 1/5. And we always state the dilations in terms of a multiplication, not a division. So multiplying by 1/5 is the same as dividing by 5. So to go back, I've got to multiply by 1/5 to get back to where I was. And I think the moving 6 units to the right is pretty self-explanatory because we moved left 6 units to -6. So if you want to go back to 0, you're going to have to go in the positive direction by 6. So 6 units right. That completes the examples for exercise 6.6, and now you should be able to do some of the combined transformations from that exercise.